Or actually good afternoon. So in the next 20 minutes or so, my topic is going to be strategies for application delivery in the cloud era, or as we like to call it in Akamai. I don't think it's our proprietary term, but we like to call it the hyper-connected world. Now, actually when I was going through the slides and the presentations that happened here before, one thing that struck me was the fact that most of the stuff that I have on the slides, at least initially, were already discussed and presented here many times in terms of enterprise mobility, cloud adoption, security, etc. I think that makes my life easier or makes my presentation faster. Or maybe what I thought I could do is actually tie it up, because all these presenters before me were talking mainly about how data center optimizations work in the cloud, how enterprise mobility is a big challenge. But I'd like to tie it up along with the major part that most of us or some of us overlook, which is the actual medium over which this data is transferred or applications are delivered, which is the internet, or for lack of a better word, the public cloud. Now, so like I said, hyper-connected world is something that we keenly, hyper-connected world is something that we keenly look at in Akamai. If you were in the introduction that I gave before, Akamai has a ringside view of the internet with 140,000 servers spread across the globe. And what we have seen across the years is a rapid explosion in all parts of the world with regards to hyperconnectivity. No one goes online anymore. I mean, if you remember a couple of years back, or maybe 7 years back in India, we used to actually term it as going online when we connect to the internet. Everyone is online, not just through their laptops, but with those multiple connected devices that we have in our pockets as iPads or phones or laptops and desktops, and even soon to come, even refrigerators and cars. And again, like I said, a lot of the slides that I want to set the premise on have been discussed before. The explosion of connected devices, along with the key factor being how, when we look at the traffic that these devices bring in and the applications that deliver over the internet bring in, even they're exploding like anything, from 6 exabytes to 43 exabytes in 2012. One of the things that we did not talk much, or we didn't have any discussion on in the last couple of days, is the fact or the factor of security that adds on to this kind of environment. What we don't realize is that along with the number of connected devices we have, along with the traffic exploding on the internet, we also have this malicious part of it called, whatever you call it, the anonymous, the hackers collective, call them people motivated by national interest, motivated by profit or corporate espionage. Even the attack traffic is exploding, or the graph is going up the same way as the number of devices are exploding and the IP traffic is exploding. And I'll talk about that in a while. So 1 Gbps to 10 Gbps. And is this the end, or is this going to remain the same way as there is a gradual shift or more of an evolution? Or is it going to be a disruption? And what we have seen is that it is indeed going to be a disruption. The graph, if we plot these various factors in, is not going to be a straight line going up, but more like a hockey stick that just peaks in the next 5 years. Because from exploding it into twice, you have number of connected devices exploding 4 times from 8 to 32 billion. The annual e-commerce spend increasing from 820 billion to 2,000 billion. And the IP traffic, again, reaching levels of 120 exabytes. And typical attack size, again, going back to the security part, goes to almost 100 Gbps. This is not the total attack size. I'm talking about a single attack that can target your data center for various reasons that I talked about. So a lot of it is good news, right? If we all are doing business on the internet, be it delivering the applications for our end users, be it getting money off our e-commerce sites or delivering media over the internet, this seems like a great news. More devices mean more money. But along with that, it brings in a lot of problems. Like I said, a lot of you might have seen different versions of this picture or diagram in a lot of slides. When we talk about the cloud or the internet or delivering anything over the internet, usually we just have the cloud data center on one side, end user on the other side, and something that represents a cloud, or it's denoted the internet or a public cloud in the middle. And it seems very simple. You have data center on one side, end user on the other side, deliver the content across to the end user. But unfortunately, that is not the case. It's not this simple. Because the cloud that we have in the middle, or what we call the middle mile, is always beset with problems. So on one side, you have data centers moving from the edge of the cloud to actually into the middle. You have cloud data centers, you have IaaS, PaaS, and SaaS providers who are part of the internet itself. And internet, as we all know, is a network of networks. A lot of these owned by ISPs who have their own motives in transferring your content from one end to the other. And the motives are usually profit, and they don't look at performance of your content as the number one priority. Now that is in the middle mile. Sorry, I'm supposed to point it somewhere here. Okay. And on the last mile, when you talk about users, even there, the hyperconnectivity is exploding. Maybe 6 or 7 years back, or as recent as 4 years back, we would have had, let's say, a single user connecting from his laptop using Windows and a version of Internet Explorer or Firefox to browse your application or the site. But right now, with the number of devices that everyone has and the number of operating systems and the browsers and environments that you have, it's really complex for someone who's trying to deliver their applications of the internet to manage this kind of complexity in the last mile. You just not have to worry about the content that you have, the application and how it is streamlined or aligned to your business objectives. You have to worry about your end users on an Android with a Galaxy Note, which has a wider screen, versus someone on an iOS, which is highly proprietary and a closed wall and has a smaller screen. Along with that adds the complexity of you add the complexity of what those users are trying to achieve with their devices and being on the internet. You have the different user behaviors or different situations that are becoming increasingly diverse. You have users who are trying to do business on the internet, trying to buy stuff from Flipkart or Amazon. You have consumer media users who are trying to watch the latest cricket match. And in terms of application delivery, when I talk about that specific user situation or experience there, I'm going to pick up 3 key areas where the challenges are being faced the most by organizations and corporations like yours, and where we can help. The first one is obviously the cloud. Simply put, how can you optimize your business transformation in the cloud when you have organizational goals such as agility or business development or getting into new markets faster? How can you enable internet to be a part of your IT infrastructure? How can you ensure that the same kind of reliability, the performance guarantee, and the visibility that you get with your private network, you can get it from the internet? So one of the key challenges with the cloud performance, again, like I said, is when the data center is far away from the end user and they have to traverse through the public internet with its own problems. Like I said before, if the content or the end user sitting here has to get the content from your data center all the way over here, most of the time what happens is that it travels through different networks of networks. It travels through the ISP closest to the end user, to the undersea cable maybe in Mumbai, goes all the way to an ISP in Dubai, and depending on the peering agreements, it's up to them on how they route it. So most of the time, and we concentrate on the bandwidth that we have in the first mile in our data center, and the bandwidth that we have in the last mile, or how much the end user has. What we neglect is the middle mile bandwidth. Like I said, this is a sample transaction we ran for one of our customers, where we found that for an enterprise application, it took no less than 31 round trips and close to 8.4 seconds for a single transaction to complete. It was something as simple as logging in to their CRM tool. And most of this latency happened in the middle mile. And this is where Akamai came into picture. If you remember my last introduction that I gave about Akamai, what we have are the Akamai Intelligence servers, part of the edge network, spread across the internet, close to the end user, and close to the origin, and it tries to mitigate the issues that this last mile has. Simply put, we know what is happening over the internet. We have the servers spread across, and what we form is a high-speed overlay over the public internet, get your content faster from the end user sitting over here to the data center where your application is hosted in the best route possible, and reduce the protocol inefficiencies and all the inefficiencies associated with your ISPs or your network providers. Again, as you can see, with Akamai, what we are able to do is reduce this middle mile total transaction time from 8 seconds to 1 second, and the round trips and the round trips from 31 to 5. And the total time required, we cut it down from 8.4 to 1.5 seconds. Along with this is the challenges that you have when your enterprise cloud is growing. Like I said, 5 or 6 years back, all you had to worry about was a single branch office, a couple of branch offices, and your application hosted in your central data center. But as and when the enterprise cloud expands, you have to use the public internet for a variety of reasons. A, it's cheaper, obviously. And B, you have a set of business partners who cannot be a part of your private network. And at the same time, you had different users who might be accessing your corporate applications, could be your employees, could be your customers, who again have to use the public internet to get on to your corporate infrastructure. And then comes on the other side, on the data center side. You would be, or most of us are moving away from a centralized hosting solution and looking at cloud providers to host your infrastructure or your platform as a service. And on the extreme end, you have the SaaS providers, the Office 365, the Oracle, the Google apps, who are actually offloading your entire infrastructure stack for an application, all the way from the application down to the network onto their data centers. So this means that you cannot be in a situation, or you cannot say that, we would be just using our own private network and all these inefficiencies don't matter to us. Because at the end of the day, with the different set of business objectives that you have, you need to use the public internet, be it to ensure that your SaaS applications are delivered to the end user, be it to ensure that your business partners are able to access your extranet or your partner portals. And this is where Akamai comes into picture. We have our, like I said, the high-speed overlay network on the internet. We have visibility into the traffic patterns of the internet. We know how your application behaves, what are the different data centers that they're hosted in, and how can we transfer the content or transfer end users to the right place at the right time, depending on performance, depending on availability, etc. And just to give you an understanding or an illustration, again, we simplify the cloud that I showed before, where rather than working on the middle mile inefficiencies, you can concentrate on delivering your applications or your content. And Akamai can optimize this entire path between the end user and the origin and much more. And I'll talk about that in a while. Is that me doing it? Sorry. And this is one of the things that we recently achieved with one of our customers globally. As you all know, Fiat Automobiles. They were having issues with their hosted dealer management solution. And without Akamai, this was the kind of response time specifically for their application hosted in North America that they were getting across the globe. So 59 seconds response time for the application without Akamai was kind of unacceptable, or as you can see, it would be unacceptable. And with Akamai, what they got was kind of like a flat line, where we were able to reduce the round trips and optimize the route and ensure that we gave what we call a near data center experience for all the users across the globe. So as you can see, the impact is felt as and further when you move away from the data center. The option Fiat had, obviously, for this would have been to build out or replicate their applications across their data centers, build out more data centers in Asia and Australia where they were facing issues, or go on a managed service model like Akamai's, where they still host it in North America, their applications in North America, but see the same kind of performance impact or a similar performance impact as a user sitting close to the data center, even when they're far away in Asia or Australia. And once they saw it, and we were monitoring it closely when they cut over to Akamai and before they were not on Akamai, and this is the response time dip, as you can see, when they moved to Akamai. And the best part is it's a managed service model. They didn't have to worry about any application changes or installing any hardware in the data center. They did a cutover at the DNS level, and instantly the application became optimized and the response times dipped greatly. And this was taken from the Asia user base. Is there a different clicker? Okay. Along with performance issues is the issue of cloud outages or data center availability. I mean, all these are taken from newspapers and articles recently where you can see that there are issues with different types of cloud models or infrastructure providers where they keep going down. And there are a lot of sites and applications which suffer because the data centers have gone down. And this is where, again, Akamai can help. With intelligent platform on which your application is delivered, such as Akamai, we have visibility into cloud outages. We have visibility into network outages, and we can understand when a particular data center actually goes down. And we know from the business logic that you have built in with Akamai that when we need to transfer that end user without facing a downtime all the way to a different data center. So if data center 1 goes down, depending on the network conditions, Akamai would be there in the picture and would know right away where exactly to transfer that particular end users to, maybe to your backup data center, in the cloud, or in-house. The second one, I mean, we talked about it quite a lot. The second trend or the challenge that enterprises face is with mobility. Till now, I was talking mainly about optimizing the cloud, or when you have applications delivered across the internet, how can you resolve the inefficiencies in the middle mile? But with mobility, it's a much bigger challenge. One of the key issues that enterprises that adopt enterprise mobility or bring your own device trend face is the expectations of the users. Now, when I used to work, or when I am accessing an enterprise application on my laptop, on my office laptop, I usually compare it with the same. I compare my email with an enterprise email someone else is using, my CRM tool with maybe my CBIL or some other enterprise tool. But when it comes to mobile users, their experiences or their expectations are actually driven by consumer app experiences. I would be looking at the Salesforce app on my phone and comparing it with, let's say, my Google Mail application or Facebook application on my phone, and wondering why it's not performing well or performing in the same level. And the main reason for that is it's no longer a simple environment like we had with constrained devices and browsers with just a laptop and a browser. The problem is that the environment and the number of applications are spread across. You have different type of browsers, you have different type of mobile operating systems which support certain web technologies, like iOS supports Flash. iOS doesn't support Flash, Android does. And the way those browsers and those complex environments interact with your application. And this is where the toughest part comes in, right? Would you rather worry about getting the right application context in place for your business drivers, or would you worry about getting all these complexities addressed? Would you worry about spending precious developer hours in addressing all these complexities that BYOD brings in? And this is where Akamai can come into picture. What we can do with what we call a front-end optimization technologies that we have for enterprise mobility is adapt according to the device type and the network conditions. A simple example is given here, where depending on the network condition that an end user has, without interference from the application or from your data center, with our own business rules and logic built in, we can decide on the type of image that is sent to the end user. Again, so you can see that depending on whether the end user is on a high-speed network or a low-speed network, we send the same different versions of the same image, onto the phone. And this is one of the examples, or one of the customers that we work with, called Standard Chartered Bank. I'm sure all of you are aware of it. And what we provided them was the performance impact in real time, and we measured it and showed it, where a set of transactions on their retail banking site, which took almost 16 seconds to complete on their data center, Akamai was able to complete in 7.7 seconds, and that shows the percentage of users who completed the transaction much before they could do it directly from the origin. And again, when we map the performance time or the time that was taken to complete this transaction, we could see that depending on where the end users are, you can see the peaks and troughs there. Where the data center is, they got like 12 seconds of response time for that whole transaction. But with Akamai, it was 8 seconds, and that was 6,000 miles from where the data center was hosted. The peaks are the ones that are using the origin data center directly, and the kind of the flat set of blue lines are the response times through Akamai. And unfortunately, I'm out of time, so I'm going to stop here. I have my colleagues and myself here for the rest of the day. If you have any questions on any of these initiatives, feel free to come and talk to us, and hope to have a good discussion.